Yeah, I submitted.
Yeah, okay. So, which is incorrect among the following?
The third one.
Yes, exactly. So, because hydrogen and oxygen, we know
Yeah.
that they have different properties. Okay. Hydrogen basically is uh, hydrogen is basically highly inflammable. Okay,
Yeah.
and the oxygen helps in combustion, but it forms water, right? So that
Yeah.
I hope is clear to you. Got it? And this you can do second. You just need to
Yeah,
take the
this
average we
was
discussed.
second one. Both A and R are true, but R is not the correct explanation.
Hmm. Now, R is actually the most abundant carbon isotope. That also is one of the options. Okay. That also because C12, why you have not taken any other atom? Why only we got down to carbon? Why? Because that is also the one of the reason. Okay, that it is the most abundant. What is the mass of one atom of C12 in grams?
So I think for this one, I did it wrong in the homework.
The fourth one.
Like what I did was there in the homework was like I did that finding the mole formula one, like 12 by
No,
Avogadro's
no,
number.
no. No need to. No need to. This fourth question, fourth.
Yeah,
What
for
will
the
be the
fourth.
mass of one atom of C12? Got it? That
Yeah,
one you are
so
talking. Hmm.
yeah,
Okay. So
so it was supposed to be like 12 into 1.67 into 10 raised to minus 24, right? To convert it into grams.
yes, yes, yes.
Yeah, I did it wrong in the assignment that I sent you.
Yeah. Okay. So Abdul, good evening. Can you hear my voice? Abdul, can you hear my voice? Am I audible? Okay. Some problem is there with respect to the connection. So this you can write it as one atom, so it is 12. Got it? One atom is 12 and put the value of U in grams.
Yeah.
So let's be very simple. If they are talking about just one atom, right? Put value on. Got it? Is that clear?
Oh, okay.
And
So
put
you
the
just
value.
have to put 1.67 into 10 raised to minus 24 only.
Exactly, exactly. Right. So that I hope is clear. And what about question fifth?
Was second one B.
1 mole of oxygen gas means 1 mole of O or O2. Abdul, am I audible? One mole of O or O2. Yeah, tell me.
Molecules of oxygen, the first A, right?
Hmm. It is actually 1 mole of oxygen gas. So how oxygen exists in nature? Does it exist as O atom or O2 molecule?
O2.
O2 molecule. Exactly. So 1 mole of oxygen gas means 1 mole of O2 molecules.
Okay.
And how much is 1 mole? How much is 1 mole? What is
One
the
mole is
number?
Avogadro's number.
Yeah, 6.022 into 10 to the power 23 oxygen
Yeah.
molecules. Okay. Molecule has 2 atoms. Each molecule has 2 atoms. Got it?
Oh, okay.
So you need to multiply by 2 if you want to get the atoms. This is incorrect. Are you getting my point?
Yeah.
Okay. Is it clear?
Yeah.
So I hope this is clear to you. Next is so how much it will be? Now you can think. What is the mass of O2? Oxygen gas is O2, right? Similarly, if I talk about nitrogen, okay, 1 mole of nitrogen. Just a second. One mole nitrogen gas. This means what?
Means 6.022 into 10 raised to 23
Is it
atoms
1
of.
mole of N or is it 1 mole of N2?
Yeah, and 2, right?
Yeah, because nitrogen in atmosphere has a formula of N2. So
Same with
one.
hydrogen.
Hmm?
Similar, it's same with the hydrogen,
Yeah,
right? It will be
exactly,
only exercise
exactly.
too.
Yes, yes, yes. So 1 mole of N2 and how many moles of nitrogen atoms? Is it 1 mole of nitrogen atom?
No,
Is
not
it
supposed to
half
be.
mole or is it the 2 moles of nitrogen atom?
Maybe half.
Suppose if I am having 2 hands, okay, how many fingers I am having totally? How will you do?
And two hands,
You will
one each hand has 5, so 10 in total.
multiply by 5. Got it? Because each hand is carrying 5 fingers. Okay, that's what
Yeah,
you did. So same thing you're going to do here also. Each molecule is carrying how many nitrogen? 2. Got it? N2.
yeah.
So how many mole? Twice the number of mole of molecules. Got it?
Okay.
Or I will give you 1 mole of water. If it is 1 mole of water, how many moles of hydrogen atoms? Tell me. How many moles of oxygen atom?
2 moles of um hydrogen atoms,
Very good. Exactly. How you did?
because H2 is there, right? So separating them will be twicing the, like, it will become
Yeah,
2. So
multiply by 2. Exactly. And how many, if you have 1 mole of water, how many mole of oxygen atoms are
1 mole, because there's no like 2 over
there?
there
Yes.
with O.
Yeah, because oxygen, each water molecule is carrying 1 oxygen.
Yeah.
What, what is the molecular mass of water? Means if you pick up one molecule, okay, which is impossible though, just a thought experiment. Okay, so what is the molecular mass of water molecule, which is H2O? Are you getting a point? Maha and Abdul both. Abdul, I can't hear your voice.
So can you like explain again?
So whenever you have one, just single molecule or single atom, write it in U. That's what I said. So
Yeah,
it is 18 U. Got it?
yeah,
So that is clear. Is that clear to you?
yeah,
And suppose if you have 1 mole of H2O molecules, means this is the complete set, which is 1 mole. What is this is known as molar mass.
yeah. It will be 18 grams, right?
Yeah, 18 gram per mole. Or just you can say 18 gram. Is this clear?
Yeah,
Okay, great. So we were discussing this. Suppose if I give you the number of, if I give you the number of molecules or number of atoms, how will you convert them to mole? Suppose if
by
I'm having,
dividing the atoms by Na, then you will get the more
yeah,
number of
exactly.
moles.
So number of mole. Yesterday we discussed the formula. Okay,
Yeah,
it is the number of entities. Entities I'm telling it in a general way. Entities could be atom, ions, molecules. Okay, whatever they are talking about. N upon N. Got it? So total, total which you are going to divide by the one set. Okay, it is just like finding dozen.
yeah,
Is that okay? It is just like finding dozen, right?
yeah,
But suppose in a dozen actually you have 12. So how many dozen? So total number divided by 12. So how many mole? Total number divided by Avogadro's. This is formula number 1. Then the moles can be found out. Number of moles by mass. Are you getting a point? So how you are, so total mass, if I give you something, some amount of mass, maybe 100 gram or 180 gram. So that whole mass actually will contain how many moles? So what you are going to do? You are going to divide the total mass by mass of 1 mole. Are you getting a point?
oh,
M
okay,
by molar mass. Mass in grams divided by molar mass, which is in gram per mole. Getting a point? This is formula number 2. So mass should be divided by mass and the number should be divided by number. Then only it will be dimensionally correct. Is it clear or not?
yeah, it's clear.
Okay. So let's take some examples. Suppose if I give you uh, okay, so suppose this is the calcium, mass number is 40, and with that I can tell you that as per our discussion, atomic mass is 40 U. Atomic mass, as the name indicates, single atom if you pick, okay,
Yeah.
that is 40 U. And molar mass, that whole group, 1 mole, that is molar mass, is 40 gram per. I hope this is clear, right?
Yeah.
That's what discussed. That is molar mass. That is, you will keep the figure same, but for one you will put U. For complete 1 mole, you are going to put gram or gram per mole. Got
Oh,
it?
okay. So for that mass 40, you have to multiply it by that 1.67 into 10 raised to minus 24 to get
No, no,
into grams.
no. It is already in grams. Just write it as gram. Gram per mole means for each mole it is 40 grams.
Yeah, but then in that formula over there, you know, number of moles equals mass and then grams,
Yeah,
right?
I'm coming to that. This is the question. I'm giving you the information. Okay, now you have to use this information. We will do that. Okay, so now
Okay.
I am asking you, this is the given in the question, that the symbol and all. Okay, now you have this data. Now I am asking you to find the number of moles in 80 grams of calcium. Find the moles in 80 grams of calcium. So what you are going to do?
To multiply the mass and the molar mass into 80.
I'm asking you what moles. Okay, so you have some amount. Got it? And to get the moles, what is the total mass? You divide by mass of 1 mole. Are you getting one point or not? It is just
Yeah.
like a box. A box weigh 20 kg. Okay, and there is it carries bricks. One brick,
Okay, so I understood like 80 by 40 you have to do.
yeah, has a mass of 4 kgs. And if I ask you how many bricks it contain, how you will tell me? That you know well. Okay. How many bricks? How will you find out? Out of 20 kg, one brick is 4 kg. So what you will do?
Okay.
Number of bricks
20
equal
by
to
4.
20 by
20 by
4.
4.
Very, very, very good. So there are 5 bricks. So same thing I am asking you here, that if I'm having 80 grams of calcium, how many moles of calcium I am having?
40 by 40. So 2 moles number of.
Exactly. Yeah, 2 moles exactly, because 1 mole has 40 gram, or you can use the unitary method also. 40 gram is 1 mole, 80 gram will be 2. Or remember the formula number 2, which tells you to ask you to find the number of moles, okay, from mass. So mass, given mass by molar mass. Got it? Given mass is 80 gram and molar mass is 40 gram. Got it?
Yeah.
Is that clear or not? Okay, great.
Yes, sir.
So now I ask you to find the number of atoms in 80 grams of calcium.
So 80 by the mass
So
of
this is the same
the
question. Actually, you have moles in the middle. Okay. If you have moles in the
yeah.
middle, one side you have mass, another side you have number. Okay. So you need to, so whatever is given to you, either mass will be given or number of atom will be given. And if it is mole given to you, then okay, well and good. You have direct moles given to you. So I'm asking you to, I have given you this. And what I'm asking? I am asking this. Getting up.
Yeah.
So from mass you need to get back to the moles. From moles you are going to apply the formula number 1. This is formula number 1, F1, and this is F2. What is F1? What is F2? Formula number 1, to get the moles from number. Number
Numbers.
divided by molar number. Avogadro's number. Got
Avogadro's
it?
numbers. Yeah.
And formula number 2, that also is giving you the mole. But when to use that? If the mass is given.
When the
Mass
masses are
divided by,
involved.
yeah, mass divided by molar mass. That will give you the number of moles. So I gave you 40 grams of calcium, 80 grams of calcium. So in order to find the mole, I applied the formula number 2, which tells me number of mole equal to m by ml, molar mass. That is equal to 2. That already we calculate 80 by 40. Got it?
Yeah.
And suppose if I want to get to the number, then number of atom, then you are going to use the formula number 1. What was formula number 1?
So you have to
Was
multiply 2 into Avogadro's number and then you will get the number of
exactly
atoms.
very good. So formula number 1 was mole equal to given number by Avogadro number. Number by number given by Avogadro. Mass by mass given by molar. Okay. So number of mole was, we have number of mole that we found out from the mass. Got it?
Yeah.
And number of calcium atom is being asked, and Avogadro number is 6.022, or you can let it continue in the NA if nobody is asking, into 20, 10 to the power 20. N equal to
So do you always have to write like the exact number or can't we just write as like 2n and leave it?
yeah, we can write it. Many places we write just 2n. That is also accepted. Correct. Absolutely correct. Sometimes they, or you can just multiply 12. You can neglect the rest of the figures. That is 0.0 point. Okay. So 12 into 10 to the power 20. 12.044 into 10 to the power 20. So I hope this is clear.
Yeah.
Okay. Abdul, am I audible? Abdul is with you in the maths also.
So I didn't take maths.
Okay. Oh, the previous class.
No, he wasn't. I think, yeah, he was in the physics class with me.
Physics class. Yeah. Okay. So I think that Abdul is able to see me. Okay. So let's move. And in case of any problem, you can stop me anytime, right? Next is, so this formula I hope is very clear. Okay.
Yeah.
And we will have more questions in the assignment of this kind. So very simple. Next is your let's talk about gases. Okay. So 1 mole of gas. One mole of gas means whatever may be the gas, it could be atomic or it could be made up of molecules. It
It's made of
occupies.
molecules, right?
It depends. It depends upon the gas. Suppose if it is helium, okay. Helium actually is atomic because helium it doesn't bind with, because it is a noble
Yeah.
gas. Okay, so noble gas doesn't combine with anything else, so it is just a monoatomic gas. So 1 mole of helium gas means how many helium atoms? Na, 1 mole, as we discussed, helium atoms.
Yeah.
Got it. What is the mass of this molar complete 1 mole? Is it just one or is it a group? Just one or a group? What it is?
What? 1 mole?
Yeah,
It's
is it
like
just one atom or a group of atoms?
group of atoms, right?
Group of atoms, because it is complete 1 mole. Got it? So
Yeah.
it is. So what is the mass? Is it 4U or is it 4 gram? 4U or 4 gram?
It'll be in grams, right?
Yeah, if it is a complete 1 mole group, that will be in gram, and if it is just one atom, it will be U. Okay, so its mass is
Yeah.
4 grams. Got it. I hope
Yeah.
it is clear to you. Got it. So, and but there is one more thing. For gases, normally we don't measure the mass. For gases, we measure the volume. Are you familiar with it? Gases are measured just like liquid. If you buy some liquid, okay, buy the gasoline or the petrol, diesel, okay, in the car, or the if you put CNG, okay, so that is in the pumps, fuel stations. We that is measured in uh, volume, okay, liters
Yeah.
or okay, cubic centimeter or cubic feet, okay, like that. The units could be different. So what is the molar volume of 1 mole of gas? That you can tell. And that is called molar volume. Volume, you understood? Volume is just like how much is it?
Yeah,
Okay,
the
it is just like,
capacity.
it is just like a balloon. How much that balloon is space is occupying? Okay, because it is a gas. It doesn't have the visible boundaries. Okay. So molar volume
Yeah.
is the volume of 1 mole of gas that is at standard temperature and pressure. Standard temperature and pressure is at 0 degrees Celsius and 1 bar pressure. It is 22.7 liters. Is it clear? 22.7. So how much is 20 liters?
Okay.
Can you give me some idea? So our
Like
water,
20
the water bottle that of mineral water is of 1 liter. Okay, that
Yeah,
bigger
2
bottle.
liters, 1 liter.
2 liters, sometimes bigger if you buy. Okay, 5 liter will be this much of big
Yeah, and then we
can.
have the 20-liter one, right? 25 liters one big.
Yeah. So 1 mole of gas, only gas, not liquid, and this is not applicable for liquids and solid. It is occupying 22.7 liter. That's a huge amount. Why that 1 mole of gas is occupying so much volume?
Because the gas there can freely move.
The gaseous particle doesn't have intermolecular force of attraction.
Yeah.
That you know. And they just move here and there. Okay, they're very light. The gas is very light, the density is very low. That you know.
Yeah, they
So
can
it is
freely
going
move around.
some, yeah, and something which is very less density, just like cotton. Okay. Small mass of cotton is going to take this much space. Okay, just like the gas, just 1 mole is going to occupy 22.7 liters. Got it? Is it clear or not?
Okay. So the smaller volume is used for gases only.
Yes. So for gases, the number of moles, if you want to find out, if I give the volume, so given volume in liters divided by 22.7. This we will be covering in the next chapters also, other chapters also.
So sir, what's the N over here? Mole of gas?
Mole. That this is the third formula applicable only for gases.
Okay.
Formula number 3 applicable for gases only. But for other substances, we talk about the mass.
Yeah.
We just talk about the mass. For gases, gases you can't weigh, you just see how much volume they are occupying. So we are talking in terms of volume.
Okay.
We are talking in terms of,
Capacity.
yeah, capacity, exactly. Okay. So this is
Okay.
the third formula. So let me move ahead to percentage composition. Percentage composition is basically suppose if you have different elements. For example, this is C6H12O6. This is, which is which molecule is this?
Ethanol. Okay.
This is glucose.
Yeah, sorry, glucose.
Yeah. So you may be very well familiar with it in the bio, right? Which is
Yeah.
synthesized in the photosynthesis. Okay, so this is glucose. What is the mass of glucose? That is 12 u into just one glucose molecule. 12 u into 6, 1 u, that is for hydrogen, into 12. And oxygen, what is the mass? 16. Got it? U into
Yeah.
6. Okay, this is 72. This is 12. This is how much? 96. And this comes around 90. So this is the molecular mass of single. If I told you if it is single, put the U. If it is 1 mole, put grams. Got it?
So aren't we supposed to put AMU?
Yeah, AMU. Earlier it was used AMU, atomic mass unit, or U is unified mass. That is one and same thing. Or
Okay.
DA, or Dalton is also used DA. Got it? I hope this is clear. Okay.
Yeah.
Now this glucose is made up of carbon, oxygen, and hydrogen. That's how you in the photosynthesis plant consume. You must be knowing as you are studying bio also, right? So
Yeah.
what is the percentage of carbon by mass? And percentage of oxygen by mass? And this is actually very easy to calculate, just uh, how we find the mass percentage. That is the only way to do. Okay. So carbon, the mass is 72. If it is You can write U or gram, not a problem. Okay, but you need to take the, if you're putting U, you should put the U at the bottom also, right? If you're talking about one molecule, that is carbon is 72U and that whole molecule is 180.
But U and grams are two different things.
Yeah, either you are talking about 1 mole, so put grams and grams in the numerator and denominator, the unit should be same. No?
Okay,
And
like that.
if you are talking about the one molecule, put U and U in the numerator, 72 by 180. Okay. The percentage is going to come out to be same because the U will get cancelled, or the gram and gram will also get cancelled. Got it?
Yeah.
Into 100. So if I ask you to find the mass, or no need to put the units, just put the mass number divided by total mass. Okay. Into 100%. So this is the percentage, elemental percentage. Are you getting
Into
it? Or?
100% means like 100 by 100.
Yeah, into 100. Yeah, 100 by 100. Yeah. So like in our body also, or in the blood also, you must have studied. Blood has certain component, and they try to figure out how much percentage is water, how much percentage is this component, how much percentage is that component. Okay.
Yeah.
So that's how. So in a molecule, if it is molecule is made up of different elements. So we try to figure out that how much percentage of carbon is there, how much percentage of oxygen is there, how much percentage of hydrogen is
But
there.
then what's the point of writing into 100%? Because it will either way cancel out, right? When we put in
Yeah,
like a fraction form.
and this one, no, we are going to simplify it and give it in number, what percentage. So how much percentage it is going to come out? 6 into 12 by 30. Mm, 4. It is, and this it is 40% carbon. This means
Also,
if we
we're not
take,
putting in a fraction form.
we can put it in the fraction. Normally we, that is a fractional amount. Okay,
Okay.
that also, but actually what happens is we feel more comfortable with the percentage. Means if you take 100 grams of glucose, that means it has 40 gram of carbon. Got it?
Okay. Yeah.
So that's why we are, you can put in, that's not absolutely correct, you can put in fraction also. Okay, but this is percentage, we are quite comfortable, that's why. So what is the percentage by mass of hydrogen present in the glucose? How to find it out? Percentage of hydrogen by mass.
So like 12 by 180.
Yeah, 12 by 180. And because
Or
I
maybe
need
like
to find,
into 60.
no, why 60?
Because 40% is being occupied by carbon, right? Out of the 100%.
No, 40 is carbon, remaining is hydrogen and oxygen. Carbon is
Yeah.
40%. Okay. So hydrogen, if I can find out, then we can easily figure out what is oxygen. You can either subtract the percentage of carbon and hydrogen from 100, or you can independently calculate by dividing 96 by 180.
Okay.
Okay. So
Yeah.
6 into 2, 6 into 3, and this is 2/3. It is how much? 20 by 3. 20 by 3 is how much? 3 into 6 is 18, and 6.67%. Are you getting a point? So hydrogen, amount of hydrogen is very less.
Yeah.
That's how you calculate the amount of sodium by percentage. Whenever we buy any ingredient, for food ingredient and for packaged food, we have that kind of percentage written on it. Okay,
Yeah.
how much percentage sodium is there? Okay, how much percentage of protein is there, and that they mention. And what percentage of oxygen by mass? That is, either you can sum them up. Okay, 46.67, 100 minus 46.67, or you can independently calculate it. 96 by how much?
180 into 100.
Got it. So it is going to be 53.3. Okay. So total sum of all the percentages, a quick check should come out to be 100. It's not that the
Okay.
percentage, if you add and it is coming out more than 100, that is wrong. Okay. That is absolutely wrong. So this is how you calculate the mass percentage of various elements. And not only elements, you must be doing it, you have done it for different things in many places. Okay. For percentage of water in the body, and percentage of carbon in bio also, bones, how much percentage of phosphorus is there, that kind of things are there in bio also. So this I hope is clear. Got it?
Yeah.
Okay, great. Now percentage composition, and now we move on to empirical formula and molecular formula. So what is the difference between these two? Empirical formula and molecular formula. Molecular formula you know already. Molecular formula is the actual formula of the molecule, and it gives the number of atoms of each element present in the molecule.
Yeah.
Number of atoms. So glucose, the formula is C6H12O6. Got it? So what
Yeah.
this formula is telling you?
So there's like 6 carbons, 12 hydrogen, and then
Yeah.
6
So
oxygen
if you
jumps.
have one molecule, means 6 atoms. One molecule contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. That's what we know. Or if we take 1 mole will have 6 mole of carbon, 12 mole of hydrogen, and 6 mole of oxygen atoms. That already we discussed.
Yeah.
And this is the molecular formula, so it is very crucial to know how many atoms of which element are there, and that is being communicated by the formula. The number are written in the subscript. Now we have empirical formula. Empirical formula is actually not the actual formula of the molecule. It gives us,
The ratio, right?
yeah, the simplest whole number ratio. Of elements present in a molecule. Ratio of the number of atoms of elements present in a molecule. Is it clear? So
Yes.
glucose, if the molecular formula is C6H12O6, what is the empirical formula of the glucose? Just cancel out the common number. So we can see that 6 is common. 6, 12, and
Yeah.
so the empirical formula is 6, just one carbon. One you don't need to write. You have 2 hydrogen, okay, and one oxygen. So it means that the carbon, hydrogen, and oxygen, it gives a ratio are in the ratio of 1 is to 2 is to 1. Empirical formula will give you the ratio of number of atoms of various elements. Ratio of number of atoms. Got it?
Okay.
So, an empirical formula, many compounds can have same empirical formula.
So, but like, what's the point of the empirical formula if it's not really correct?
Yeah, it is giving us some information, the ratios. Okay, but actually, while doing the finding the molecular formula, just you will see that first you get the empirical formula, from there you get the molecular formula. For explanation, because you were familiar, I told you molecular formula first and then empirical formula.
Yeah.
So but if you try to figure out the how the formula is found out, you will find that it is the empirical formula. It is the mass percentage which is given first. Mass percentage to empirical formula means a ratio of atoms, number of atoms, then empirical formula to molecular formula. That's how you get. So what's the use of empirical formula? Actually, it is not the final destination. It is just one point while getting from the mass percentage to actual formula. While deriving the actual formula from mass percentages, you pass through empirical formula. Okay, so different compound.
Okay.
So we will see the example also. Different compound can have same empirical formulas. Yes. Okay, for example, this is which molecule? This is this molecule. So in bio lab, when we go, we have seen the samples of dead organisms, okay, preserved samples. You know that?
Yeah, I did see.
Yeah, you may see some dead frogs and snakes and all
Yeah.
stored in bio lab. Okay, they are preserved in formalin solution. This is formalin solution, methanol. Okay, they make a solution and that is used as a preservative for those, right? So
Okay.
this is methanol or formaldehyde, and this is acetic acid which is there in the vinegar. You are already familiar. So
Yeah.
what's the formula? And what's the formula for this? H4C2. And what's the are you getting a point?
But isn't it like C2H4O2?
C2, yeah, C2H4, exactly. So, and for glucose, you already know C6H12O6. So the ratio, or I can write the hydrogen because I am writing hydrogen first, H12C6O6. So the molecular formulas are different. Okay.
Yeah.
And when you find their empirical formulas, so it is the same as molecular formula. In this, you are going to cancel the two, H2CO. This from this formula, you are going to cancel the whole number 6, divide by 6. Got it?
Okay. So H2CO.
Yeah, H2CO. So they will have same. They will have same. So it is a matter of coincidence. But
Okay.
empirical formula is same doesn't mean the molecule is same. Even if the molecular formula is
Okay.
same, then also the molecule can be different. They can have different isomers. So if we are getting the same empirical formula, it is just a matter of coincidence, right?
Yeah.
Empirical formula, suppose how to get to the molecular formula by empirical formula. So empirical formula, if somebody provides me, I need to multiply, I need to get that whole number. Somehow I need to get the whole number. For this, the whole number is 6. For this, the whole number is 2. For this, the whole number by which it should be multiplied to get the actual formula is 1. Getting a point or not?
Okay. Yeah.
So empirical formula, you need to multiply it by certain whole number, and you will get the molecular formula. And if you divide the molecular formula with certain whole number, that which is common among both the all the elements, you get the empirical formula. This is one thing. Okay. And the other thing is how to get the whole number. You can get it by mass, by knowing the how to get n. How to get the value of n, the whole number. That is by knowing the by comparing the molar mass and empirical formula mass. For example, a compound X, compound X is there, and that compound X has empirical formula of CH2O. Its molar mass. Molar mass is for the molecule, complete molecule. Okay.
Okay.
Its molar mass is 180. So let's say 60. Find its molecular formula. Are you getting my point?
Yeah. But then, like, how do you find the molecular formula?
Okay. So we know that empirical formula, whatever is there, that is incomplete.
Yeah.
Because and that you need to multiply it by some whole number by which you divided the molecular formula. So you need to multiply it back to get the molecular formula. This you know. Okay.
Yeah.
So you need to,
Do we have to find the mass of the empirical
yeah,
formula?
yeah, exactly. So you can apply the same funda on the mass. So empirical formula mass will be into N, will be molar mass, molecular formula of mass, or the molar mass.
Okay, so 60 by empirical mass.
Yeah, so you can what is the mass of this empirical formula? This is 12 plus, I'm not writing U or gram because I just need a number.
Yeah.
12 plus 2 plus 16. And this is how much? 16 and 4, 20, 20, 30. So this is 30 into N. N, I need to figure out what is the value of N. And the
N will be
mass,
2.
N will be 2. This is equal to 60, N equal to 2. So by comparing the masses, the empirical formula masses with the molar mass, you can get the value of N, and you can get the value of the molecular formula. So what will be the molecular formula of the compound? CH2O was empirical formula. So you need to multiply it by 2. You need to make it twice. Got it? It is going to be C2H4O. Is it clear or not?
Yeah.
Just
Okay.
so mass, we were having empirical formula that you can easily calculate. Okay, and molar mass will be given to you. So you can figure out by what whole number I need to multiply the empirical formula mass to get the molar, to make it equal to molar mass. You can get the N. So if you get the N from by comparing the masses, you can also put that N in the formula. Empirical formula, you can multiply it by that N, you will get the molecular formula. Getting my point or
Yeah.
not? So
Yeah.
that is very, right, very easy. So just by comparing the masses, you can get the value of the whole number, and you need to multiply that empirical formula by the whole number to get the molecular formula.
Okay.
So just
Yeah.
now actually you were asking what is the use of empirical formula, and I told you that empirical formula is used to get the molecular formula, and that's what we are doing. We are finding the value of N, and we're building up the molecular formula, right?
Yeah.
Okay.
Mm.
Next is how to find the empirical formula. How to find the empirical formula from the mass percentage. From the mass percentage of elements. So suppose if a question comes, a compound is there. Okay, by experiment you can determine how much percentage of carbon is there, how much percentage hydrogen is there. That you will be also be able to do at the last of your class 11. Okay,
Okay.
it is there in the second book. Okay, how to do. But as of now, I'm telling you that this is the percentage. The compound contains 4.07% hydrogen. It contains 24.27 percentage carbon. It contains 71.65% of chlorine by mass. Got it? So what is the empirical formula?
So do we have to find the empirical formula like of each of the percentages or like total?
Yeah, total. Actually, what we do, because we are running out of time, just I will tell you the picture and in next class. So we have mass percentage. Okay. From mass percentage, you can get the empirical formula. Okay. From empirical formula, you get the molecular formula. Okay. That's how you get up to the molecular formula. Mass percentage is given. Okay.
So sum of those percentages will be the mass percentage.
Now, sum of that, take that percentage as gram, divide and find the moles of each atom. I will assume that I have taken 100 gram of this compound. That will have 75.65% chlorine, 24% carbon, and 4% hydrogen. I will assume that, and I will
Okay.
based on that I will find the number of their moles. So 4 mole, 2 mole, and 2 mole. Roughly, I'm telling, not doing the exact calculation. Hydrogen are divided by 1. That is roughly around 4. Carbon I divided by 12. The mass is 12. So that is 2 mole. And chlorine I divided by 35. So that is also 2 mole.
Yeah.
So I get the number of moles of atoms. I get the ratio. Now I compare the empirical formula mass and the molar mass. So that's how I get the formula. Okay, so rough idea I already told you. So let's
Okay.
continue it on the next one. And next one also we are going to start with the uh, calculations related to chemical equation. Okay.
Okay.
Okay. So
So
let's
when do the weekly tests start from?
yeah, just we will cover up. Initially, it may take little bit of time, and just we get into the flow